Welcome to this live stream of another game engine in my quest to search for a game engine I can use for an upcoming game development project I'm looking for. In which I want to stream the whole development process and the research process of the game. It's called Bear Whale. It is a crypto game, like running on a cryptocurrency. And I want to program it in Rust because I really like the language and I want to really get more time spending in Rust. So now today we are looking at the QuickSilver engine, and I want to also edit. I want the chat to be enabled. So toggle timestamp. Well, ask any questions screen. I will just check these messages once in a while, if anybody is watching, of course. Create highlight video, share live stream settings. That means live chat. Enable. Yes. Enable slow mode. No. Okay, so everything is enabled. So let's go and look. So QuickSilver has a promise that also runs for web, and this is something I'm looking for. So I really like it. So you have a few versions. So if you look at the tags, we have like the 0.3 version and the alpha version, which we're working hard on. I'm using the 0.4 version because I like living on the edge. So I just pasted this thing in. So let's look at it. What I already like, I also studied Amethyst in our previous streams, and I tried making a tutorial, spent a few hours figuring it out. What I already saw, it's like a big package, right, with a lot of dependencies and a lot of stuff that are going around, which I actually don't need, right? I rather implement such a thing myself if it's needed, and especially for prototyping. I just want something small, and I don't want to like start digging around in all kinds of libraries and ways of doing things. So Amethyst is like a very structured language, and QuickSilver promises something lighter, but it also promises posting to web, and this is something I really need. And I'm also going to look at it today. So I really like this. It's small. There's a simple run function, which takes care of the window and all that stuff. You know, I don't really care about handling this. So, and then it's a simple app which settings default. So I'm just trying to figure this out. What is this? What is these settings? These are settings, and I can do all kinds of things. And we have a default setting, default modus, which I also like for prototyping because it's like quick. Yeah? You don't have to think about too much. Size, we have an icon, we can full screen, yes or no. Icon path, multi-sampling, I have no idea what it is. Virtual sync is true. Resizable, false. We have a warm log level, and use static there is true, which we could set to false. Okay, and then we have one function, it's the run function. And what it describes here, it provides your application represented by async closure of function with a window. So is this async? Ah, interesting. We have an application that's asynchronous, and the run function takes a settings object, which we imported from here, and so we could for example, okay. So it takes settings and an app. An app is a type F, and it is static lifetime, and it is an event once, which has a create windows, which create a window. So what is this? This is also part struct window. This is the window on the user desktop on the browser tab. Nice. Nice. Because this web, I like the web stuff, right? So here we have graphics and inputs. So this function, which we have to pass, takes a window object, a graphics object, and an input. So let's see what the graphics object is. We have context, we have a vertex buffer, element buffer, shader program, vertex index, image changes, projection changes, geometrical mode changes, clear changes. What is clear changes? Okay, blend mode changes, and we have like a transform. So let's read a bit. Struct draw calls on the GPU. The basic flow of graphics is a loop of clear, draw, and present. When drawing, keep in mind the projection transformation. The projection is set by graphics set projection and usually transform orthographic. Is a transformation applied to every single vertex. You get a law of linear algebra, and it's advised to keep it constant as much as possible. The word transformation is used to rotate, scale, or translate a handful of draw calls, and is set by graphics set perform. For best performance, try to reduce unnecessary state changes. Sources of changes include changing the image you're drawing, okay, changing the projection, or changing the type of geometry drawing. That makes absolute sense. And we also have an input. So if you make a game, to the event stream, event cache, so you can even cache them. Cool. Retrieve the next event. Okay, so this is pretty cool. So just from a high level perspective, you could say the following, that a game is a function of a window with a graphics output and an input. The only thing we're missing here is the sound, which is probably then another library, and it is asynchronously, so it's like it's running in another thread, or let's see how they implemented this. So the function, that's also right, has to be static. So blinds async match. So here everything is set up. And here. Oh, let's run. This is run and then it awaits. Is this a loop or something? Run GL blinds. So this is another library that's called blinds. So let's see what that does. Blinds, rest, blinds. Windowing, an async API for windowing. So that's what it does, window and an event stream. And then it runs something. Okay. So that makes sense. So we run GL is a function that blinds has. Run GL. And set things into So it also needs a setting map. So this is probably like it's a different one. But I saw already an into function, so there's a setting from implemented, and here we move the ownership of the window context events into here. Interesting. So does what is this? It's not async, huh? No, it's not an async function. Okay. Alright. So let's go back to main. So what this thing does is clear. It makes a rectangle and then it presents it on the window. So that's what it meant. It's like clear, draw all kinds of stuff and then present it on the window. This is a borrowed reference and can fail. So a result is returned here. You can do a QuickSilver error. Interesting. So what is this? Some image parsing, IO error, because the file didn't load it. Graphics error, it's big problems. And some other errors. If it's a font, okay. So, and then is it this here with a loop, which essentially does nothing. And I expect that closing the window is then handled separately because we don't need to take care of this, which I also like, right? So using this tool allows me essentially to just to include something. I have the main and I have the app and I can just start experimenting with anything I like. So this is a very good thing. So let's just execute it and bam, we have a nice square on the screen. So this is good enough essentially to look at some more examples. I also looked at piston before, didn't like it as well, and I didn't have a. Okay, so first of all, let's try to do a web export, right? So let's see, is it do a web export? Web. Deploying to the web. Yes, I already have this all installed. Then use web deploy to build the application located at target deploy. If you want to test your application locally, web starts. Features standard web and open to the report events. Well, isn't this fascinating? If this would work, then I'm sold. Then I am sold. QuickSilver, and let's do Bearware. So package Bearware does not have these features. Standard web. Okay. So there's. Is this a feature? Let's do a search. Rust. Let's create. It's to provide was binding to web APIs that allow having was in JavaScript. Okay. So can I just add it? Okay, let's try it. QuickSilver, cargo add standard web. Optional. Do we need this? Do we need this? Let's do deploy. Because it doesn't seem to have the feature. It's a lot of errors. That is a lot of errors, and it's on Please select the feature to build for web. Okay. So maybe let's do feature. And that is deflate, or where is it? Platform implemented, way in it. Let's do it standard web. Features. So there's way in it. Okay. So how do we build the web? Web. So how do we deploy fails? Because I need to specify feature and the glow. So maybe it's just cargo dot features QuickSilver. Maybe it's on there. So let's see. Features default, easy log, standard web, error web sys. Okay, let's start. Let's do standard web. Exactly. So I should release these. I just forgot to cover list features. How does it work to means first? Features. And pages. Features. Yeah, features. Okay. This looks better. So that's perfect. Okay. So we even have a choice between what kind of abstraction you want. That's crazy. That's some really cool stuff going on here. So it's perfect. It's like the perfect balance for projects that need, let's say, like a quick way of experimentation with graphics without too much overhead, right? And then if you need that whole structure from entity component system like Amethyst, then you just use this. Piston is another thing to look at, but I don't know for sure if they have like a WebAssembly export or anything like this. But if I can export this just like to the web, that would be amazing. So let's read some more while we're waiting. So QuickSilver, blah 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 blah. Let's look at the examples. We have a square image, RGB triangle. So I think this will all be the same, and then different. So it's all the same build up. Render to texture. So this is now the surface image. It's a bit more low level, but that's good. That's good. Blending. White, set blend mode. Effect. So timers. What are timers? Okay, so this is deployed. And what was the other one? Web deploy. There was another one. Cargo web deploy. Web start. Exactly. And now at 8,000 we should have our rendering ready. That would be crazy. If that's done, then I think we can close this stream, and the next stream I will start building something concrete. That's amazing. This is amazing. Unbelievable. Does this run onto the canvas? Yeah, it runs to the canvas. Width, height. Beautiful. And we have like source code here. Let's see how that looks. There will JavaScript and WASM. Wow. So if the JavaScript and the WASM is integrated, that's amazing. That is amazing. That saves so much time. So why can't I scroll? Okay, so this is all kind of. This is probably the bind gen, right? Store new up. Okay. Cargo web. How big is this thing? Yeah, yeah. Web malloc free. So how big is this? Well, here we have like some sweet WebAssembly code. Brilliant. So how big? I don't know how big it is. Network. Let's do a reload. Home. Jesus. That's a lot of code. How big was this? 3.6 megabytes. What? That is a lot of size. Maybe if we do a release build. I don't know if it's possible. Cargo web help. Cargo web. Okay. Cargo. I want the release. I want to have a cargo deploy. release build. Release. Okay. So cargo web deploy release. But can I do cargo web start? Release. Yes. Okay. So if this release mode makes it smaller, because 3.6 megabytes is a little bit big for web game, but still acceptable, but big. I cannot imagine that all this is being packaged and sent over the. I hope it optimizes it more. Maybe we can optimize it more, essentially, like make it smaller. I hope so. I think what would be acceptable? What would be acceptable for a game? That's always a good question, of course. What's acceptable? Oh, I got a message. Thank you. Thank you, Super. Is there anything? So let's do the timestamps. What was this? Let's do time back. This is the. Okay, I want to see. Extra. The system is a bit slow. We're compiling. So see, like this release build takes a lot. It takes a lot of time. OBS is slurping like 140, 150. Where's my Rust? Where's my Rust? Analyzer. Where's my build? That's cargo. I would imagine more CPU being used by. OBS is like 2 processors. Regulate sync is busy all the time. This is a renderer, takes 20%. This is probably the renderer I use for the Amethyst cable thing. Oh, I don't hope I killed the stream. Oh, damn, I killed the stream. I hope it's still on. I hope it's still on. Okay, that's good. It's still on. Okay. So that was the stream. Let's see, how far is he? 805. Is he stopped or something? I don't know. This one is always big. This was a big crate built for these procedural macros in Rust. I'm sitting in the Netherlands. It's around 5 o'clock here, so I'm waiting for this build to continue because I wanted to have I want to see how big this QuickSilver engine is for game compilation on the client side. That is very important to know. And what I'm also going to do is going to share the stream to the team. They can also, where is the, how do I share the stream? This is my stream right now, right? Let's see. Is this the stream? What happened? Share the stream to the team. They can also. Interesting. Where is the, how do I share the stream? That's pretty cool. Now I'm looking at myself, talking with a delay. That's pretty cool. So here, I can go to setting. What the hell? That's pretty cool. So there we go. There was some stuff in Dutch. So now let's see. Now it's compiling the standard web. I think now, if you look at the size of the thing, target. So what I always like to do, 1.6 gigabytes of dependencies there in debug. Deploy 3.5 megabytes. That was the web deploy. Release takes 212 megabytes, and this wasn't 2. Target, this is like the target to build for the web, is 272. But what you notice is that this cargo web deployment, right, is amazing. Like, it takes away all the complexity. At least let's hope that it does it. But I only find this thing to take so long. Oh, here we got it. Here we got 2 processes now working like crazy. This OBS is taking a lot of time. It's taking up a lot of my things. I'm gonna pause this one for a while. It's probably pause. It's doing a lot of energy. And this one, Windows Server, is also taking a lot of space and time. Look at them go, huh? It goes very well. So zeta dupe. So maybe in between, what I normally do is just like play like a quick game of chess, just to keep the mind on something else. So afterwards I can focus on. It's gonna take a while to build. So I'm just curious. I don't know if you're still watching Zeta Dupe. Are you still? Do you like Rust? Do you like the language, or were you interested, or are you interested in just development in general? Or is it strong player? Wow. What the hell? Am I 15? 15 plus 8. Okay, it's a long game. It wasn't idea. So I like this variation. So let's see, are we done yet? No, WebGL generator is busy building the release version. So let's do it like this. And let's do it like this. I like this can setup, right? You've got all the black fields. A lot of control. This one is biting like a hard point in the position. This can be exchanged, often happens. So since he played this, right, I'll just play this. And then if he does here, he will also move. Right. We got some response from the teammates. Okay. Unreal Engine. The Unreal Engine. So let's go. I knew it, huh? I knew he would move it two times. So he is doing what? Ja, maar mag wel binnenkomen. Wat is dat, Bol? Is hij los? Oeh, heftig.
Ja, ik kan mijn vinger eronder steken.
Oké. Ik ben wel aan het streamen, hè?
Ja.
Oké.
Ja, mag ik ik wil ook filmen.
Oh. Maar ik ga hem eerst opnemen dan.
Ja.
Ja? Right. So what are we gonna do? Still. Oh. He's done. So let this player wait. So it's at 8,000 now. Where did we have it? Here. So how big is it now? Beowulf Wasm? That's better. So we have the whole game engine, everything in production mode in this level for 780 kilobytes. I don't know if you can zoom this in. So we can see like the Beowulf Wasm is 780 kilobytes and the Beowulf JavaScript, the bindings is 60. And then we have localhost. So this is promising. It is pretty promising. Let's see. Maybe the bells. Where is it? Where did we put it? Where did we put it? Square example, exactly. Didn't I also, unbelievable, it also did the naming. It took the naming here. You see this? Square example, it took the name from the code. That is pretty cool. Square. So the tab is also named immediately. This is really cool. And of course we will have probably like an index function which only has a canvas. And this will be probably in the deploy, which is not visible here. So let's go back. Target deploy. Now release. Release and the deploy is here. And the index. We got Cargo Web. This is handled by Cargo Web probably. And this is being created by Cargo Web. So it depends it here. It creates it essentially the canvas element here. Interesting. And we have some settings here. There's going to be some questions about resizing and stuff like that, right? Which we can figure out later. But this looks really, really well. So if you look at the amount of code you need to get something on the screen, right? I definitely prefer it about over Amethyst. It's like probably good for big games with a lot of assets and neat is ECB structure, this entity component system structure. What I really would like is, for example, to have this, and then, for example, like this entity component system that you can use on top of QuickSilver, which hooks into the whole system. Because in the end, you could argue that everything, you know, that the entity component system does in the end is render either like it parses input. Let's say it depends on how you set it up, but it will just render stuff on the graphics. Yeah? So in that sense, this looks pretty good. But also the difference between essentially a development build and the release build is also very interesting to see, is that the difference is enormous. But let's first reload it to see if it actually works, and it renders. That's perfect. So I think this is good enough for this stream. So next stream on QuickSilver, I'll just start building something moving essentially, and start implementing the basic logic of like a proof of concept implementation of the barrel game. Alright, thank you very much, and see you next time.